G'day again, guys. Mill power feed. That's what this one's about. I decided to go down the route of using a stepper motor. Main reason being was to try and get it as compact as I possibly could, because being a small mill table, I didn't want to lose any of the travel. So you can see, just mucking around with the design, see if it'd sort of work and whatever. So it doesn't interfere with the travel at all. You'll see later in the videos that whole section slides like into the V's of the dovetails. So yeah, I lose no travel. Got a couple of pulleys and had to machine out the guts of them to make them fit on the shafts. Just test fitting it there. I didn't really have any idea what I was going to need, roughly, but yeah. So I just went to a shop and I bought quite a few different bits and pieces, just in case I needed them. It's a bloody long drive for me to get back there to buy something different. So I just got a few different sizes, and I was pretty spot on with the original one. So used it and it worked out. Yeah, making up the brackets, the thrust bearing and everything. Found out later that I needed one on the other side, which was a real bastard. But it worked one way and not the other. That's all mounted up. Shitty welding. It's the motor bracket section of it. Everything was an afterthought, like always. But yeah, I mean it worked. That's the motor bracket finalised. Come up right. And that's completely butchered and welded together. That's it, it's still going strong. It just looks bad. Well, it looks good there, sort of. I don't know what you call them. Is that something like a dog joint? Or, I don't know. But yeah, you can see the little teethy things. Come out good. Worked well. I don't know what the names of things are. No idea. That's all mounted up. That's what you call clearance. So this here is what I was talking about. Not losing any travel. And you can see it's going right into into the dovetails and hits the stop. That's it. Full travel. To the stop. Bodged up the wiring just to see if it would actually work. And I didn't have a what do you call it? I didn't have a power supply at that stage, so I was using a laptop charger. And it worked. Moving on to the cover for it. Just some sheet, folded it up and welded up the edges and cleaned it up. Nothing special. Wiring. I was pretty pleased with myself with this one. I figured out a way that I could stop the back EMF, I think it's called. It's where when you crank the handle, being a stepper motor, it feeds current, whatever you want to call it, back into the driver and can damage it. So what I actually did was wired it in a way that it actually cuts the connection for each coil of the motor to the driver. So when I switch it off, it breaks the connection. So it literally can't, it can't backfeed the current. However you want to say that. It's probably not the right way of doing it, but it hasn't caught fire and hasn't had any dramas whatsoever, and the driver still works, so I'm calling it a success. Power feed's finished finally. It killed me, it's done. That's it. Simple. Nice and clean. Put a box under there. I think it's the most compact fucking thing ever. But it's worked well. That's it. Just a note here that I had some of the settings wrong. So, you know, she goes, stuffed around a bit, tweaked it, and now it's, you know, smooth as. This video is pretty old now, so since then I've actually updated the power supply. Went a much larger one, and also I found that the stepper motor wasn't quite powerful enough, so I went to the largest size I could find in a NEMA 23, and like maximum torque, and that's on there now, and it's beautiful now. It's perfect. I had to lose the handle because I ran out of room for it. I've got to make up more different things for it. I just haven't got around to it. It works, and yeah, it's been good. But I'll get around to finishing it one day. All right, cheers.